Hello, this is Rafael Jabba for the Gloucester High School, and what I have here is my Lidar project. So what this project mainly uses is a Lidar sensor and an LCD screen, which are two new devices that we're learning how to use right now. So the Lidar sensor, it will send out a beam of light from one end. You can see that there's two lenses, and receive it in the other, and we'll basically see how long it takes for it to receive that signal. And it uses that to measure the distance. And for my project, that is getting sent back to the main processor or the Arduino, and that value, which is in centimeters, is being sent to the LCD screen, which is just displayed as that number in centimeters. Here's my code for this project. Up here you can see all the libraries that I need to be using for it. This is the main library for the LiDAR sensor. This is the one to be able to use the I2C, the communication with the LiDAR sensor. And here we also have the library for the LCD screen, which will be displaying the distance. This is just something to set up the library, as well as this. This is for the LiDAR to just set the name of it, and this is to declare the ports that the LCD screen is using. Up here is the setup code. This is just runs once at the beginning of the program to set variables and things like that. Right here, this will start the serial monitor, which you can see already working down here. And then this just sets the settings for the library to default. And similar thing with this, just sets the size of the LCD you're using. This is 16 by 2, so there's 16 characters by 2 characters tall, but you can get bigger and smaller screens. The next main part is just the loop, which continuously repeats. Up at the top, I clear the screen so any old numbers aren't left over. For example, if I had a 300 before, but I want to print a 20 after, you'd still see numbers from the 300 even if you just printed a 20. So they would all overlap on top of each other and be really weird. So that gets rid of that. And this also creates the variable for the distance that's being read. This right here will tell the LCD to print at that specific coordinate. And this right here is the main part that will set the distance variable equal to the reading from the LiDAR. This right here or these two lines, are printing that variable to this serial monitor right here. You can see that working right now, because right now I'm holding my hand above it, and it slowly starts to come down. It does glitch a little bit if you move your hand around a little. Sometimes it'll say 400, but if I leave my hand out, you can see it goes back to 140, meaning that from my desk to the ceiling is 140 centimeter. And if I put my hand a little bit above it, it'll maybe go to 7, and I keep going up, and the number keeps going up. And I'll show this in a second, but this will print basically the same thing, but instead of on the computer screen, go to the LCD screen. And this will just make the numbers easier to read, because if they were changing any faster than that, there'd just be a blur on the screen. So this is the project right here. You can see I have a capacitor, potentiometer for contrast on the LCD screen, as well as 2 resistors for the LiDAR sensor that it needs for the I2C connection. So you can see here I have 5 different, actually no, that would be 6 connections to the Arduino for the main data for this. And over here we have 4 connections. You can see the 2 unused ones, mainly the power, the ground, which are black and red, and the SCL and SDA, which are the blue and green wires. So you can see that it's currently displaying about 139, 138. It's not the most accurate, but does do the job. So right now I'm going to put my hand above it. And now it will be saying, keep going to around. So between like 7 and 40 centimeters as I'm putting my hand up and down. Now if I take my hand off of it, it goes all the way back to 140, which is the ceiling height up there. You can see here I have the main schematic for my circuit. Right here you can see the Arduino, the main microcontroller for this project. And I also have the Lidar sensor right here with 4 pins. Normally it has 6, but I'm not using 2 of them, so only 4 are connected right here. The positive, negative, and the 2 I2C connections. This one is the clock, and this one is the data line, which both connects to the clock and data line ports of the Arduino. There's also a capacitor for power for the Lidar, and also resistors for the SDL and SDA I2C connections. Here is the 16:2 LCD, and sometimes you can do I2C connections with LCD, but since this already used I2C, I'd rather just use parallel. So this uses more connections, but it's easier to set up when you have something else using I2C.